Today, we'll be going through lessons 15 and 16, representing situations with inequalities. Okay, we're going to start with this warm-up. Turn to page 214 and attempt to do this on your own. Match each inequality, A, B, and C, to the meaning of the symbol within it. So you want to look at H greater than 50 and tell me what that symbol right here means. Do the same thing for B and C. And then go to question 2 and answer, is 25 a solution to any of the inequalities? Which ones? Try to do the same thing for 3 and 4. All right, pause your video, go to page 214 in your workbook, and then come back and check your answers. Starting with A, H greater than 50. You can substitute numbers in here, then check for a true statement. Think of numbers that are greater than 50. So this symbol matches with greater than. When you see a line underneath the greater than or less than symbol, you're going to include equal with that as well. So for B, H less than or equal to 20, any numbers that are less than 20 or equal to 20. So that could be 20, because 20 is equal to 20, or it could be 19, because 19 is less than 20, and so forth. So this middle symbol here is less than or equal to. Moving on to C, greater than or equal to, including equal, greater than or equal to. You need to pay close attention to not just the inequality, but whether the inequality contains the equal sign as well. All right, is 25 a solution to any of the inequalities? So let's check. Substitute in 25 for H. Is 25 greater than 50? The answer is no. 25 is not greater than 50. It's less than 50. Now let's substitute in 25 for B. Is 25 less than or equal to 20? It could be either less than, which is 25 is not less than 20, and 25 is not equal to 20, so that's not true. So let's move on to C and substitute in 25 for H. Is 30 greater than 25? Yes, it is. It's not equal to, but it is greater. So yes, C, 25 is a solution to the inequality 30 is greater than or equal to H. Question number 3, is 40 a solution to any of the inequalities? Which ones? So we're going to do the same thing. We're going to take that 40 and we're going to substitute it in to A. Is 40 greater than 50? The answer is no. Let's move to B. Is 40 less than or equal to 20? No. On the number line, 40 is not less than or equal to 20. 40 is greater than 20. Move on to C. Plug in or substitute in 40 for H. Is 30 greater than 40 or equal to 40? And the answer is no. None of those work. Moving on to C. We're going to now substitute in 30 for H. Is 30 greater than 30? The answer is no. But we have the equal underneath. So is 30 equal to 30? The answer is yes. So greater than or equal to makes C true. So yes, it's a solution to C. All right, moving on. This is not in the workbook, so just find a place and take notes if you need to, or follow along. For each of these, I want you to think of an example where H would be greater than 50. So what could you substitute in for H to make this statement true? Choose a value that's greater than 50. I'm going to choose 100, and then I'm going to test that to see if that's true. Is 100 greater than 50? Yes, 100 is greater than 50. So I chose a value that worked. Now there are several others. 1,000 is greater than 50, 75 is greater than 50, 51 is greater than 50. But because this does not include an equal to as well, we can't put 50, substitute in 50 for h. It just has to be values greater than 50. For h less than or equal to 20, we can substitute in 20 to make this true, because it does include the equal sign on the bottom. But 20 is not less than 20, but it is equal to. It's less than or equal to. Or any numbers less than 20, such as 19, that works, because we have the less than or equal to. You can think of others as well. 0 works. Anything on the number line to the left of 20. All right, the third one, 30 greater than or equal to h. Think of some values for h that would make this true. What about 0? Is 30 greater than or equal to 0? Just test it out. Yes, 30 is greater than or equal to 0. Try some other numbers. What about 50? Is 30 greater than or equal to 50? No. And you could try several numbers to get an idea of what this means. Now, is 30 greater than or equal to 30? The answer is yes. You can use that number because we included the equal to sign as well. Looking on the right column, the only thing that works to substitute in to make this a true statement for h is 50. 50 equal to, there's only one answer, 50. So what about this one? What could you substitute in for h to make this a true statement? The only number that makes that true is 20. The same thing for the last one. The only number you can substitute in for h to make that true is 30. Okay, turn to page 215 in your workbook. We're going to work through Activity 1, Elevator Constraints. Read through the scenario. An elevator car and a skyscraper can hold at most 15 people. So we have a constraint here. We cannot go over 15 people in the elevator car. For safety reasons, each car can carry a maximum of 1,500 kilograms. So we don't want to go over the weight limit. There's another constraint of 1,500 kilograms, because if it gets too heavy, it could drop. On average, an adult weighs 70 kilograms and a child weighs 35 kilograms. Assume that each person carries 4 kilograms of gear with them. So in addition to the 70 kilograms for each person, we're going to have to add on another 4 kilograms, and the same thing for children, 35 plus another 4 kilograms. Now, we're not doing this in class, so do this on your own. Follow the steps to complete the table. The table is on page 216, so let's turn to page 216 and we'll go through this together. I'll explain how it works, and then you'll try a few of these on your own. We said that it can hold at most 15 people. So I'm going to use P as my variable. You can choose any variable. We're going to define what those variables are in that last column. So I'm going to say P, number of people, has to be less than or equal to 15. So explain what you're doing. The elevator car in a skyscraper can hold at most 15 people. Then tell me what those variables are that you wrote. P represents the number of people in an elevator car. A second one that's partially complete is W equals 70A plus 35C plus 4A plus 4C. Okay, so let me define the variables for you. A is the number of adults. C is going to represent the number of children in the car. And W is going to represent the weight in kilograms that one elevator car can carry. So 70, because each adult weighs 70 kilograms, times A, the number of adults, plus 35, because 35 is how much a child weighs, times the number of children, I'm going to use C as that variable, plus 4 times the number of adults, because we're adding on 4 kilograms each for each adult and 4 kilograms each for each child, all of that equals the total weight. All right, so you're going to explain in words what this equation represents. Total weight in elevator would equal to 70 kilograms times the number of adults plus 35 kilograms times the number of children plus 4 kilograms times the number of adults and 4 kilograms times the number of children. So we're putting into words what we talked through in this equation. All right, I want you to come up with an example of your own, and there could be different examples. I don't have them here, but let's see if we can work backward. All right, try to follow along. All right, in the word problem, let me get my pen here. In the word problem, it said the elevator weight limit is 1,500 kilograms. Okay, for safety, we do not want to exceed that. All right, so define your variables. I'm going to use t. You can use whatever variables you want. So I'm going to say t is the total amount of weight that the elevator should carry. All right, so the maximum weight of 1,500 kilograms. All right, the elevator weight limit is 1,500 kilograms. We're not going to exceed that for safety. So the total weight has to be less than or equal to 1,500. All right, let's see if we can pick something else out of that word problem. All right, the weight limit is 1,500 kilograms. I'm going to take the W for weight limit. If you look up here on row 2, we have W equals 70A plus 35C plus 4A plus 4C. I'm going to take that expression and substitute it into W. And I'm going to tell you what the variables represent. A is the number of adults, C is the number of children, and T, the total, has to be less than or equal to 1,500 kilograms. Total weight. All right, so I'm going to write all of this. I'm going to substitute that in for total weight. So 70, in other words, I'm going to substitute it in here for the total weight. I used a different variable here. Maybe I should have used W. So I'm going to write 70A plus 35C plus 4A plus 4C less than or equal to 1,500. Now you can choose whatever variables you want. We're just trying to put this together in an expression or using your constraints and inequality. So let's move on. All right, complete this cool down on your own. It may be, if it's in Canvas, go ahead and turn it into Canvas. If not, just include it somewhere in your book. This is not in your workbook, by the way, so copy and complete it on page 217. So that way you'll have it in case we need to turn it in. All right, Han has a budget of $25 to buy grapes. Write inequalities to represent the number of pounds of grapes that Han could buy in each situation. If grapes cost $1.99 per pound. So I'm going to use the variable G for grapes. You can use any variable you want, just make sure you write down what it represents. So $1.99 times G has to be, what is the budget? Think about the budget. Not equal to 25. It could be equal to 25. Get it right on the money. But it also could be less than 25. So less than or equal to 25. Let's see if we got that right. All right, looks like we got it right. All right, the next one, $2.49 per pound. So you're going to multiply $2.49 times the number of pounds of grapes. So I'm going to use G for my variable for the number of pounds of grapes. So that's going to be $2.49 times G has to be less than or equal to 25. So using this pattern, we're multiplying the cost per pound times the number of pounds, and it has to be under or equal to $25 because that's all we have to buy grapes. So that expression would be the cost times the number of pounds of grapes less than or equal to 25. Go through, starting on page 218, go through your summary and glossary, look at the examples, make sure that you understand what we've covered because we go through this pretty quickly, but you always have your glossary and summary that you should go over on your own. Make sure that you know what these symbols are and you'll be fine on your test, but you need to know what they are. Greater than, less than, greater than or equal to, less than or equal to. All right, go through, read through all of this. Again, highlight things that are not as familiar. Come back with questions tomorrow and we'll complete our review in class and take our test on Unit 2 on Wednesday. All right, let's go into the next lesson and get this done very quickly, and you can do some practice problems. All right, complete the bridge on page 224. This is lesson 16. We want to solve each inequality for x. Now I want to make sure that you pay attention to this because something's going to come up we haven't talked about yet, and it will be on the test on Wednesday. All right, we're going to solve these like we solve equations. We're going to start by looking at both sides and simplifying if we can. On the left-hand side, we have a variable term and we have a constant term. These are not like terms, so we can't combine them. On the right-hand side, we have a constant, 12.6. So there's nothing that we can do on the right to simplify. So now we're going to start trying to undo everything that's around this variable using reverse order of operations. So we're going to start with addition, subtraction. I can see we're adding 3. So the opposite of add 3 is subtract 3. I'm going to subtract 3 from both sides. Always think about what you're moving from the left-hand side or trying to get rid of on the left-hand side. It will not combine with anything other than constant terms. So we happen to have a constant term, 12.6, and we can combine those. So I've lined them up underneath each other. 3 take away 3 is 0. I'm not going to write that 0, but I still have 3x left. So bring down the 3x. Bring down the less than, and then 12.6 minus 3 is 9.6. One more step, divide both sides by 3. And 3 divided by 3 is 1. 3 into 3 is 1. 3 into 3 is 1. Or you can think of it this way. Anything over itself is 1. So all we're left with is 1x. So I'm going to write that x here. 1 times x is x. Bring down the less than, and then use your calculator to divide 9.6 by 3. 9 divided by 3 is 3, and 6, put the decimal here, 6 divided by 3 is 2. So the answer should be 3.2. All right, moving on to question number 2. We're going to solve this inequality the same way. We're going to start by adding 2 to both sides. To get rid of the 2 on the left, this is going to become 0, so I'll just cross it out. But whatever you do to the left, you have to do to the right. So remember that you added 2. We're going to add 2 here. All right, now let's bring down the 4x. That's all that's left on the left. 4x greater than 24. Divide both sides by 4. Whatever you do to the left, you have to do to the right. 4 divided by 4 is 1, so you have 1x greater than 24 divided by 4 is 6. Now the only thing we have to be careful about when we're solving inequalities is if we ever multiply or divide through the inequality by a negative, this symbol is going to reverse, and we're going to see that coming up. It will also be on the test. All right, warm up. I want you to think of one solution to the inequality y less than or equal to 9.2. Give me any number. Now, answers can vary here, so your answer won't necessarily look like mine or your neighbor's, but find a solution that works. You might want to stop, think, pause the video, and then come back. What I came up with is 0. Is 0 less than or equal to 9.2? All right, I'm going to find 9.2 on the number line. It's going to be somewhere between 9 and 10. And then here's 0. Here's what I chose. Now 0 is to the left of 9.2, so it is less than. So my example worked, but you could choose any of these numbers. -1, -2, -3.5, -10. You could choose 8, 7. You could even choose 9. 4, 3, 2. Any of those numbers makes a solution to that inequality. All right, on this one, write one solution to the inequality 7 times 3 minus x greater than 14. Now, in order to solve this, you need to simplify both sides. The right-hand side is already simplified. It's 14. So let's bring down that 14, bring down the greater than, and let's simplify, work on simplifying the left-hand side. So distribute we're multiplying 7. We're going to distribute it to both terms in parentheses. So let's start with 7 times 3. 7 times 3 is 21. And then 7 times x, don't forget there's a minus in between. 7 times x is 7x. All right, now we can work on isolating that variable. So we're going to start with reverse order of operations and get our constants on the right. So I'm going to subtract 21 from both sides. Subtract 21 from 21, and of course that's going to be 0. So I'll just cross through that. Bring down the -7, -7x. Bring down the greater than symbol, and then 14 minus 21. Use your calculator, and that is equal to -7. Now here's where I said we're going to have to slow down, and remember that in order to solve for x, you need to divide both sides by whatever you're multiplying to x to undo that. Divide by -7, divide by -7, and if you forget that when you divide through by a negative number, this inequality symbol is going to flip. That's what gives us the most trouble until we practice and get really good at this. So don't forget that on your test. So this is going to be 1x, bring down the 1x. And then -7 divided by 7 is also 1. We don't have any variable attached to that, so it's just going to be 1. All right, so we're going to find 1. It's not equal to 1, so we're going to circle it. Find 1 on the number line. And then we're going to shade everything to the left. And shade everything to the left. So this is how you would graph the inequality, and this would be your solution. All right, turn to page 225. A teacher is choosing between two options for a class field trip to an orchard. Look at orchard A. Admission costs $9 per person. So if we start with 8 students and then we add the 3 chaperones that are required, how many people total do we have? 8, 9, 10, 11. So for orchard A, this is going to be 11 times 9. that would be $99. But for Orchard B, it's going to be 8 plus 1 for a total of 9. So that would be $90 for 9 people. Now let's move down to this scenario. Scenario B. Okay. Oh, I'm sorry. Scenario B. Yeah, that's right. So 12 at Orchard A costs $9 per person, but you've got to add on 3 chaperones. So what's 12 plus 3 chaperones? 12 plus 3 would be 15. 12 students, 3 chaperones, 15 total, times 9. That's for Orchard A. And then for Orchard B, we have 12 students plus 1 more. That would be 13. See, we only need 1 additional, times 10. All right, so 15 times 9 would be $135. And then if we go to Orchard B, it would cost us $130. So now it looks like it's still less than, but it's getting closer to what that amount is for Orchard A. We're only saving $5 by going to Orchard B. Here it would be $9. Let's see what happens with 30 students. Okay, so with 30 students, we've got to add on 3 for Orchard A. So that would be 33 times 9. $297. Now, for Orchard B, we're only adding in 1 additional person, so that would be 31, and we're multiplying by 10. So 31 times 10, can you do that in your head? $310. All right, so which one would you choose in this first scenario with 8 students? The cheaper option would be Orchard B. And it's still cheaper with 12 students. But when we get to 30 students, it's going to be cheaper to go to Orchard A with those 3 chaperones. All right, to help her compare the cost of the 2 options, the teacher first writes the equation 9 times n plus 3. Now let's think about this. The number of students plus 3 chaperones, that's Orchard A, times 9. Cost of admission is $9 for each person. In Orchard B, it costs $10 per person, but we're only adding in the number of students plus 1 chaperone. So she writes this equality, and then she writes the inequality. So we're taking those same expressions on the left side and the right-hand side, but we're replacing the equal with the less than. Okay, what does n represent in each statement? N is the number of students on the field trip. In this situation, what does the equation 9 times n plus 3 equals 10 times n plus 1 mean? What that means is, when does visiting either Orchard A or Orchard B come up with the same amount of students that cost, the same amount of cost, total cost? When is that going to be equal? How many students would we have to put in here to make that equal? What does the solution to the inequality 9 times n plus 3 less than 10 times n plus 1 tell us? It tells us that when it will cost less to visit Orchard A, because that's the one that costs $9 per person. Okay, so whatever we get here, it's going to tell us, if we substitute in a number here like we compared on the tables, it's going to tell us when it costs less to visit Orchard A. To help her compare the cost of her two options, the teacher first writes this equation and this inequality, which we just saw. To determine the solution set to the inequality 9 times n plus 3 less than 10 times n plus 1. If you solve that, you should get n is greater than 17. Now I want you to notice before I show you how to solve this, before we work through this, and I want you to take notes in your workbook. This has changed direction, so we must be multiplying or dividing through by a negative somewhere in here. So let's follow the steps. We're going to simplify the left-hand side by using the distributive property to multiply 9 to both terms. So 9 times n is 9n. And then 9 times 3, we have plus in between, is 27. We have the less than symbol. On the right-hand side, we have to distribute the multiplication by 10 into both terms. So we have 10n plus 10. All right, I'm going to follow the steps that we've been taking, moving the constants to the right. So I'm going to subtract 27 from both sides, and I'm going to line up the 27 that I'm subtracting from the left and the right. On the right-hand side, I'm going to line it up underneath that constant 10. On the left-hand side, 27 minus 27 is 0. Bring down the 9 times n, it's 9n. Bring down the less than symbol. Bring down the 10n. And then 10 minus 27 is negative 17. Right now I'm going to move the variable terms to the left-hand side. I'm going to start by subtracting the variable term on the right-hand side, 10n. And I have to keep this balanced by subtracting it on the left-hand side as well. Draw your line. 9 take away 10 is negative 1n. You can write the 1. I'll go ahead and write it so you can see it. Now that's multiplication. This is going to cross out. We're going to get 0. Write your less than, bring down the negative 17. All right, now divide both sides by negative 1. And when you divide by negative 1, or you multiply by negative 1, anything over itself is 1. That's going to make this n positive. This is going to flip around because we did that division by negative 1. Negative divided by negative is a positive. 17 divided by 1 is 17. So that's how we got this answer. Activity number 2, solve this equation and check your solution. Now we don't have to worry about the sign flipping. So a lot of times I'll see you write a line that goes down like this. Okay, but there are some things that we need to be careful and work slowly through or we'll miss it. All right, the first thing I see is there's one term on the left. It's a negative term. I'm dividing by 5. So in order to get rid of that 5, I'm going to, or make it go away, make this equation easier to solve, I'm going to multiply both sides by 5. Now you've got to be careful on the right. You have two terms that you have to distribute the multiplication to both terms. So make sure you're writing it carefully, not losing your steps so that you can see what we're doing. All right, you can write this as 5 over 1 on the left-hand side, or you can just reason it out. We're undoing division. Here's our division right here. When we have something in the denominator, it's always dividing by that number. So to undo the division, we're going to multiply. So that's going to cross out. We're going to have 5 over 5, which is just 1. So bring down the negative, don't lose the negative, and the 4 times x plus 3. Now that negative was kind of in the middle, but when we got rid of that denominator, it's gonna be with the 4. So it's going to be negative 4. So we're distributing a negative 4 into both terms. Let's go ahead and do that multiplication. Negative 4 times x is negative 4x. And then negative 4 times positive 3 is, you can write this as plus a negative 12, or you can write it as minus 12. Okay, now let's move to the right hand side and distribute the 5. 5 times 4 is 20, x, and then minus 5 times 12 is 60. All right, now start solving it. It should look a little easier now. We're going to add that 12 to both sides. Draw that line all the way across. And then 12, take away 12. That's going to be 0. I'm not going to write the 0. I'm just going to bring down the negative 4x. Bring down your equal. Bring down the 20x. And then what is 60 minus 12? On the test, make sure that you're showing your work if you need to. Don't just do it in your head. What I'm saying is use your calculator to check. What is negative 60 plus 12? That is going to be a negative 48. All right, now we need to get those variable terms on the left, so subtract 20x from both sides. Minus 20x. Draw your line. Negative 20x plus a negative 4x, not 40, negative 4x is negative 24x equal, and then this is going to be 0. I'll go ahead and write that over here. Negative 48. Divide both sides by negative 24. And a negative divided by a negative, you can think of this a couple of different ways, is a positive. 24 divided by 24 is 1. Or you can just say anything divided by itself, anything over itself is 1. So x is equal to a negative divided by a negative is a positive. 48 divided by 24 is 2. And that should be our answer. Let's uncover it and let's see if we got it correct. All right, we did. All right, activity 2, consider the inequality negative 4 times x plus 3 over 5 less than or equal to 4x minus 12. It first asks us, are the values less than 2 solutions to the inequality? So think about your number line and think about numbers that are less than 2. So I'm going to put 0, 1, 2, negative 1, negative 2, so forth. All right, any of these numbers that are in this direction are less than 2. So pick a number that you'd like to work with. I'm going to choose 0. So negative 4 times 0, we're substituting in 0 for x. 0 plus 3 would be 3 over 5. On the left hand side simplifies to negative 12/5. And we're asking if that's going to be less than or equal to 4 times 0, this time we're going to put in 0 here, is 0, minus 12 is minus 12. Divide 12 by 5 and you get 2.4. All right, but it's negative. Don't forget that negative. Is that less than or equal to negative 12? Well, if this were positive, it would be less than, but 2.4, negative 2.4 is going to be somewhere right here, and negative 12 is going to be way over here. So this is not true. Now let's look at any of the values greater than 2. So let's just pick 3. Substitute that in. 3 plus 3 is 6. 6 times 4 is 24. 24 divided by 5, and it's going to be negative. Don't forget the negative right here, because that will mess you up. Less than or equal to, and we substituted in, do you remember what we substituted in for x? We substituted in 3. It's less than or equal to, 4 times 3 is 12, and 12 minus 12 is 0. Now, is any negative number less than 0? And you can see that it is. So this is yes. Now we're going to choose 2 for x, and we're going to plug it in. So 4 times 2 plus 3 is 5 over 5. 4 times 5 is 20. 20 divided by 5 is 4. But this is a common mistake. Don't forget that this is negative. So that's negative 4. We're checking to see if that's less than or equal to, substituting in the same 2 for x on the right hand side. So we're going to put a 2 right here. 2 times 4 is 8, and 8 minus 12 is negative 4. So is that a true statement? And the answer is yes, because we have that equal sign. All right, now consider this inequality that we've been looking at, and we want to graph that on the number line. All right, now if we solve this inequality, you're going to see, and I'll show you how this inequality flips around. Okay, we're going to start by, and I think we might have already done this, we multiply both sides by 5. And we have a negative out here. So let's just multiply both sides by 5 to start with. So this 5 that we're multiplying by, then divide by 5, this is going to cancel, and we still have negative 4 times x plus 3 on the top. Okay, less than or equal to, distribute the 5. 5 times 4 is 20. We have x minus 12 times 5 is 60. Okay, now on the left hand side, distribute the negative 4, negative 4x. And then negative 4 times 3 is negative 12. Bring down the less than or equal to, and we have 20x minus 60. Now, we've already solved this. Let's just work through it again one more time. I think we've solved it. All right. What am I doing? This is negative, not negative 20, negative 12. We're adding 12 to both sides. My hand starts to hurt, and then I want to rush through, so don't rush. This is 0. Bring down the negative 4x. Less than or equal to 20x. And then negative 60 plus 12 is 48. Oh, here we go. Is negative 48. Okay, now we have to subtract 20x from both sides. To get those variable terms on the left. So this is going to cross out. That's going to be 0. We're left with negative 48. Less than or equal to, on the left hand side, we've got negative 20x, and the negative 4x is negative 24x. Now divide both sides by negative 24, and this is how your inequality symbol changes direction. So you will see these on the test, so make sure that you remember when you multiply or divide by a negative, this is going to change direction. Okay, anything divided by itself is 1. So we have 1x greater than or equal to, negative divided by negative is a positive, 48 divided by 24 is 2. All right, now we've got to circle in 2 because it's equal to 2, and then shade in to the right. So that's our solution. Go through the student summary and glossary. Make sure that you're highlighting, underlining, understanding. Especially important that you do this now before we take our test. Know how to solve inequalities, and what's important is if you multiply or divide by negative, the direction of that inequality changes. And then shade in the direction that the arrow is pointing on the graph. All right, your practice problems, I want you to try these before tomorrow. Come back and then we'll go over these. You'll turn those in before we complete our review. You have to be in class and present, participating in the review. I'm not sure whether or not you're going to use it on your test, but it may give you extra credit on your test if you come to class, participate, and get this completed during class.